Graphing velocity using reference points is the next journal entry. These are supplies you're going to need. You're going to need 3 colors. I recommend like a highlighter. Works the best. This will all be doing on the paper and then gluing at the end. So for right now, before I forget, grab your journal, open up to your table of contents. Now we just did the lab, how fast and how far. If you go back to that took pages 7, 8, and 9. Okay? So go ahead and write a little 7-9 right there to remind you that now we're going to be on page 10. Okay? So this journal entry will go on page 10. Again, title is right there on your paper. Graphing velocity using reference point. Okay, and yes, there will be a practice worksheet on this. You won't most likely do today, but another time. Okay, so now you can take your journal and just set it aside. We are going to do everything on the paper. Now that paper, first thing you need to do is cut off the border. And that little title up there, don't need that. I'm going to be writing that title in by hand. Okay. Just cut the border. That's all you're going to cut today. That's just cutting off that border. So it should only take you a minute. And you can put that trash to the side. Okay. So, starting up here at the top. Up here, these, which you're actually looking at, are XY axes. Alright? X-axis is the horizontal axis. Y-axis is the vertical axis. Okay? You should hopefully have known that and know that from algebra. Okay? Now, when we're graphing velocity, there's a few things important for you to know. Okay? So, that what we call reference point. Reference point is where the position is equal to 0. Now, position can also be the displacement, or it can be the distance. It all depends on what you're talking about. If we're talking about velocity, it's displacement. But speed and velocity, so very similar. Sometimes it'll be a distance graph. Okay? Excuse me. Take a color. I'm using green. My 3 colors are pink, yellow, pink, orange, and green. Okay? I'm going to start with my green. Highlight this. Reference point in one of your colors. Reference point is where the position is equal to 0 meters. Okay? And you can also highlight displacement. Alright? So the reference point is where the displacement or the position is equal to 0. Well, if you have an X and Y axis intersecting each other, the Y time is always on the X axis. Okay? Time is on the X axis. Here in this graph, X axis right here. Time is on the X axis. Up here, time is always on the X axis. So on the Y axis is where we're going to have displacement. So displacement is going to be on our Y axis. Now, if you're thinking about displacement, remember where the 2 axes intersect, that is 0, 0. And so these numbers as you're going up, they're positive. Okay? Where the 2 axes intersect is 0, 0. As you go up, those are positive. Okay? So give yourself a big plus sign here. Positive position. Okay. Plus sign. We're going to make this pink. We're going to make positive pink. Okay? Now, where we have the reference point, where the displacement is equal to 0, so there's those numbers like 10, 20, so 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Displacement is equal to 0 along the x-axis. Okay? These numbers, 5, 4, 3, 2, 1, 0. Alright, that 0 right there for displacement, again, is your x-axis. Over here we have, sorry, highlight positive here, give yourself the plus sign. Alright. Over here, our displacement, our intersection 0, 0. Okay. The displacement is 0 there, and the numbers as you go down are now negative. So this is my third color. This is going to be the negative. Negative position. And over here we've got, again, the numbers as you go down. These are negative. Okay. We're still going to use those colors, so keep them there. Alright, so trying to visualize this on a graph, positive and negative. Okay, now we have 3 different examples here. We have a car, we've got a truck, we've got a motorcycle. We're going to talk about those 3. We're going to do this with examples. When it comes to graphing, it's an understanding difficult concepts like graphing. It's all about the examples and doing examples in practice. Okay, so let's start off talking about reference point. Reference point is where the position is equal to 0. So let's look at our car. We have a 6 meters, 5, 4, 3, 2, 1, 0. So our reference point is where our position is equal to 0. Now, to help you understand reference point a little bit, we are going to, basically reference point is the point from which we view the world, the point of perspective on the movement of the objects. The reference point is fixed. And to help clarify that, to make this easier, we're going to draw a stick man standing on the reference point. Okay? Now, the interesting thing about the reference point, it has a positive and negative position. So we have the positive stuff in front of him and the negative stuff behind him. So we need to emphasize that he's facing the positive direction. So you're going to show feet on him, and you're going to show him facing the positive direction. Okay? You're going to kind of give him a little bit of a smiley face there. Alright, let's see if we can get focus on that. That's what I want your little stick man to look like, okay? He's facing that direction. His toes are pointing that way, and he's got one eye and half a smile there, so he's facing that direction. Okay? Alright. So these are all positive positions. Well, we chose pink to be our positive color, so I'm going to highlight those all in pink. Alright. Now, we are going to graph the motion of this. In order to graph it, we need to add, we have position information, but we need to know the times. So, for the sake of this graph, we're going to say the car, this is where he is at 0 seconds. Alright, he's at a position of 1 meter, or a displacement of 1 meter at 0 seconds. 3 meters is his position or displacement at 6 seconds. So we know that he is moving that direction, and we actually call that the positive direction. Okay? So we have here a graph. Y-axis, x-axis. Alright, where these two intersect. So we have, as you see up here, the displacement is your y-axis. Time is on your x-axis. Okay? And where the displacement is equal to 0, that is the reference point. Okay? So we have here positive numbers going up. So let's go ahead and label these 1, 2, 3, 4. Okay? Positive numbers for pink. Positive numbers. That's what we're working with here. Okay? So let's graph the motion of this car. So at a time of 0, so let's count out our seconds here. This is going to be 1 second, 2 seconds, 3, 4, 5, 6, 7. Okay? Let me give you a close-up here of my graph and how it's looking. Okay? So 1 second, 2 second, 3 second, 4 second, 5, 6, 7 seconds. And then displacement, positives 1, 2, 3, 4 going up. Okay? Alright. Now let's graph this. Well, at 0 seconds, at a time of 0 seconds, so 0 seconds is actually right here, the car has a position of 1 meter, so right there. 0 seconds, 1 meter, that is the first point. 6 seconds later, 1, 2, 3, 4, 5, 6 seconds later, he's now at 3 meters. So it's 6 seconds, 3 meters. Okay? Now we have 2 dots, and we are going to connect those and draw a straight line. And that is the graph for the car. Alright, let's graph the truck. Always think about reference point. Reference point, reference point. Reference point is where the position or the displacement is equal to 0. Okay? So go ahead and highlight that in your color for displacement. Draw your stick man. But remember, you need to point him facing the positive direction. Well, you see got negative numbers here, positive numbers here. He is facing to the right. Okay? So stickman is facing this direction. Now, our truck, at 0 seconds, he is positioned at 3 meters. 6 seconds later, he's at position negative 3 meters. So we know that he's moving to the left. Okay? And if we pay attention to numbers, he's got both has positive and negative position during that 6 seconds. Okay? So this graph is going to be both in the positive region and in the negative region of the graph. Okay? So we have displacement on the y-axis. We have time on the x-axis. Okay? Going up the axis, 1, 2, 3, 4. Down, -1, -2, -3, -4, and -5. Okay? Time, where it intersects is 0. Then it's 1, 2, 3, 4, 5, 6, 7 seconds. Okay? Let me get you a close-up on that graph. Once it's all labeled, that's about what it should look like. Okay? Now we have to draw the graph. Let's plot it. Okay? So at a time of 0 seconds, so 3, 2, 1, 0, the position of the truck is 3 meters. So positive 3 meters at a time of 0. Okay? 6 seconds later, so 1, 2, 3, 4, 5, 6 seconds later, he's now in a position of -3. So -3 meters and 6 seconds. We get a dot right there. And now that's all the data we have for the truck, so all we're going to do is connect those dots. And we will have a graph for the truck. There we go. Now, let's pause for a moment. Our car moving in a positive direction. Because the numbers are getting bigger. Our truck is moving in the negative direction. Notice they're going opposite directions. He's going to the right. Generally speaking, moving to the right is positive. The truck is moving in the negative direction. Okay, and you can think about the reference point. If that stick figure man started to walk, he'd walk in the positive direction. The truck is going the opposite direction, or what direction is it facing? And that left is usually your negative direction. Okay, so the car is moving to the right, moving in the positive direction. The truck is moving to the left, the negative direction. So you can see how this slope goes up and that slope goes down. And if you remember to algebra, we have a positive slope and that is a negative slope. So that helps you understand that idea of what the slope can tell you. All right. Our last graph is for the motorcycle. Okay, so we have our reference point where our displacement or position is equal to 0. Okay, I'm going to draw my stick figure man there. Feet facing in the positive direction, so his back is to the negative numbers. Okay, and so this graph, the motorcycle is only ever in a negative position, so I'm going to highlight those as negative numbers, emphasize that. Our graph is only going to be in the negative region, okay, on the plot. And our reference point, right there. Okay, 0 seconds, sorry, 0 seconds, that's where the motorcycle is, and it moves to the left to 6 seconds. Alright, it's moving in the negative direction. Which traditionally is moving to the left. Alright, so let's plot these points. Well, sorry, a little more detail here. Displacement of 0, and then go down that graph, -1, -2, -3, -4, -5. Okay, and then going up in time, we've got 1, 2, 3, 4, 5, 6, 7 seconds. This is time. Okay, at a time of 0 seconds, the motorcycle was at a -1 position. So 3, 2, 1, 0 seconds, -1 displacement from the reference point. And at 6 seconds, 1, 2, 3, 4, 5, 6 seconds, a -6, sorry, -5, a -5 displacement. Okay, so at 6 is at a -5. Connect the dots. Now notice both our truck and our motorcycle are going the same direction. They're both going the negative direction, both going to the left, and they both have a negative slope. Difference between the truck and the motorcycle, the truck is actually traveling much faster. The truck moved a distance of 6 meters in those 6 seconds, where the motorcycle only moved 4 meters. And so if you notice, if you look at it carefully, this line is much steeper than that line. This slope on the truck is steeper than the slope on the motorcycle. That tells me it's going faster and that they're going the same direction. The car here is the slowest. It has the least steep slope and it's moving in the positive direction. So it has the least steep slope, and therefore it's going the slowest. It only moved 2 meters in 6 seconds. Okay, so that is the first part of this journal entry, and let's go ahead and get it glued in. Okay, so find page 10 in your journal. Right in the page number 10. Get your glue, and we're just going to glue that in. Make sure you leave space at the top. You're going to write your title in. Alright. And the title, Graphing Velocity with reference point. Okay. So that's our page 10. Now it's time to go on. We are going that. This journal entry is not done. Okay. We still need to do some practice work on the oops page. Okay. So you should get this piece of paper. Alright, this lovely piece of paper we're going to put on the oops page. So, nice practice. So, oops page, do not turn the page. Right there on the facing page on the left side. That's where we're going to put this in. Okay? Go ahead and trim off the extra off this graph. Trim off the extra edge. Okay? Like I said, this is going on the oops page. Make sure you do not turn the page. It's right there facing page 10. Okay? This graph, go ahead and glue it in using just a very little bit of glue because we are going to be writing on it, but it needs to be stuck in before you write on it. So go ahead and glue it towards the top page right there. Alright. So we are going to be doing some practice velocity graphs. We call these velocity graphs. Okay? Now velocity graph, displacement versus time. Time is always on the x-axis. Okay? So time is our variable on the x-axis. Over here on the y-axis, this is where we have displacement. Okay? So time and displacement. Now, if it's a distance graph, we're graphing speed rather than velocity. Basically talking about the same thing. Just the velocity is going to have direction. Most of the graphs will say displacement. You might see one that says distance, but for the most part, we just deal with displacement. Every once in a while, you'll also see them called position. Might be position in there. It still means the same thing. Position, displacement, distance. You'd read all these graphs pretty much the same way. All right. Now to do this part, you need to have 5 different colors. Now I recommend colored pencils. If you have colored pens, great. Highlighters, if you have a good point tip on them, that's fine. If you are borrowing from my stuff, if you can't find 5 colors, that's fine. Use the colors you've got and then trade with a neighbor. Okay, share with a neighbor, and you can add a total of 5. Okay, I'm going to be using blue, green, purple, brown, and red. And we are going to do some graphing, so we also need to have a ruler. Okay, so here we go. Let's start. This is going to be just a whole bunch of examples we're going to graph together. Okay, so we are going to pick a color, any color. I'm going to start with my red. Okay, I'm going to make a little key down here. So my red graph, this is going to be representing an object at rest. Now, that phrase, you might not know what that means. Okay, that means it's not moving. So the physics way of saying an object is not moving, we say it's at rest. Okay, so we're going to draw a graph for an object that is at rest in a positive position, or you can say with a positive displacement. All right, so with that same color, go to your graph, displacement, positive numbers. We're going to do it up to 5. Okay, so right here. So let's say you're 5 meters from the reference point. And a second later, if you are at rest, you're still going to be 5 meters from the reference point. Okay? At 2 seconds, so a second after that, if you're at rest, you're still going to be 5 meters from the reference point. At 3 seconds, you will still be 5 meters from the reference point. At 4 seconds, you will still be 5 meters from the reference point if you are not moving. Okay? So, go ahead and connect those dots. Take the graph all the way to the end of the page as well if you want to. Okay? That is what it looks like when you graph an object at rest in a positive position. Okay? Now, what about an object at rest in a not positive position? Okay? Well, let's see what we can do with that. So I'm going to do my brown. Okay? Little key for that. Object is at rest in a negative position. Okay, or you can say with a negative displacement. Let's put it at a -4. Okay, so 4 meters to the left of the reference point. A second later, if you're at rest, you're still -4 meters from the reference point. A second later, still -4, still -4. So that is the object at rest at a position of -4 from the reference point. Alright, now let's do a graph that's in motion. Okay, I'm going to use green for this graph. Okay, and this one we are going to do, we're going to have the object start at the reference point. And we are going to have it move in the positive direction. With a constant velocity, which means that velocity doesn't change. And we're going to give it a speed of 1 meter per second. So constant velocity of 1 meter per second. Okay? So if I'm going to start at the reference point, the displacement, 0, right here, where the two axes intersect. So we're going to start right there. And 1 meter per second means that every second that passes, its velocity is going to move 1 meter. So we'll move from 0 to 1 in the positive direction. A second later, it will move 1 meter more. A second after that, 1 meter more. A second after that, a meter more. And you can see that pattern. Nice straight line, connect the dots. go. Next graph, let's do starting in a negative position. So blue. Let's do blue. Okay. Let's start in negative position. And for the sake of this graph, let's make it a -6 meters. Okay? And then we're going to move with a constant positive velocity of 3 meters per second. Okay, so starting at a negative position, -6 meters. So right here on the graph, that's where we're going to start. So at time 0, -6 meters, that's going to be our first point. Okay, and we're going to move a velocity of 3 meters per second, which means every second we're going to increase by 3 meters. So every second, so from 1 to 2 seconds, we're going to go from -3 to -2 to -1 to 0. And then over the next second, we're going to go to a +3, and over the next second to a +6, going by 3s. All right, and connect the dots. Okay, so that is a graph starting in a negative position, going in the positive direction. If you notice, at 2 seconds, it actually crosses the reference point there. Now, if you want to, you can emphasize a little bit better. This didn't print as dark as I wanted it to. Those axes. Trying to make it a little bit darker, you're welcome to. Alright. Last graph we're going to do. I'm going to do this one in purple. There we go. We're going to start this time in a positive position. And we're going to make that a +6 meters. And we are going to move with a constant negative velocity of -2 meters per second. Okay? So what does that negative tell us? Well, we learned from over here, negative slope means it's going to be going downward. Positive slope goes the upward. So a negative slope. So starting +6, position of +6. So with my purple, here we go. Starting +6, time 0, +6. And every second that passes, so from 0 to 1 second, we're going to decrease by 2 meters. So -2, so 6 goes to 4. Over the next second, we'll go down 2 more meters, so from 4 to 2. Over the next second, 2 more meters, so down to 0. Over the next second, 2 more meters, so down to -2. Over the next second, 2 more meters, -4. And the next second gets us all the way to -6. Connected the dots. Okay, so that's what your graph should look like. Okay, now one little note I want to give down here at the bottom. It's going to be very, very helpful. Okay. If it's a straight line, we call that linear. Okay, we call it a linear graph. All of these are linear graphs. They're all straight lines. I'll do them all with a nice straight ruler. Okay? When you have a linear graph, that means the motion is constant. Okay, it's not changing. Whatever it is constant. So in here we have a constant negative velocity. On the blue one we had a constant positive velocity. On the green one we had a constant positive velocity. Now this at rest. Alright, what these are here, we can call these a constant position. Because his position isn't changing. Okay, so the red and the brown, these two linear graphs, the ones that are at rest, those are constantly, those have a constant position. These have a constant velocity. So in a displacement or distance graph, that linear means a constant velocity or a constant speed, or it means a constant position if it's horizontal. Okay, we will be learning more about other graphs, so you do need to learn that this is a displacement versus time graph, where the slope of the line tells you the speed. Okay, and that is graphing velocity with reference point.